All right, so today we are looking at section 12.2 and several definitions to start with. First off, a prism is going to be a polyhedron with two congruent faces that lie in parallel planes. Right, so it's a polyhedron, so it's a closed figure with all the faces that are polygons. And then in that figure, there are going to be two congruent faces. Right, they're going to be parallel to each other. And those congruent faces are going to be what we call the bases. So like here, we have a prism. The top and bottom are congruent to each other, both squares here. So those would be the bases. Lateral faces are going to be the parallelograms formed by connecting the corresponding vertices of the bases. So basically we have a base on the top and bottom here, and then all of these rectangles going around the sides would be the lateral faces. A right prism is going to be a prism in which each lateral edge is perpendicular to both bases. So it's perfectly perpendicular up and down here. An oblique prism is going to be a prism that has lateral edges that are not perpendicular to the base. So it'll be a prism that looks more like this, where it's kind of leaning to the side. Right? So it's not going straight up and down from the base, from one base up to the other base. Right. And then the slant height is going to be the length of one of those oblique lateral edges. So when we have an oblique prism, the total length of that angled side there is going to be a slant height. And then the actual height is how high it is from the ground up to the top, but this distance is not quite as long as the slant height would be. And surface area is going to be the sum of the areas of all the faces of the polyhedron. So if you figure out the area of all 6 faces of this prism, then that would be the total surface area. Lateral area is just the sum of the areas of the lateral faces. So basically it's the surface area minus the area of the 2 bases would be the lateral area. And then a net is a 2-dimensional representation of all the faces of a polyhedron or other geometric solid. Really, a net is kind of like if we had a box and we opened it up and flattened it out, so it was just one flat sheet of cardboard, then we could see all the pieces, how they folded back together to make the box that we start out with. So we have a picture of a net right here. I don't know what geometric solid is represented by the following net. So if we took this flat net and folded it back together to put it into a solid, then it would look something like this. So something like that, which would be a prism. Right? You have 2 congruent faces and a bunch of lateral faces going around it. And to name it, then we look at what the congruent bases are, and those are hexagons. So it's going to be a hexagonal prism. Bases are hexagons, and it's a prism, so it's a hexagonal prism. The next one says, find the surface area of a right rectangular prism with a height of 2 inches, a length of 5 inches, and a width of 4 inches. So anytime that you're asked to find a surface area or something of a prism, sometimes it's helpful to kind of draw it, give yourself a little bit of a reference to look at. So we got a prism, 5 inches, 4 inches, and a height of 2 inches. So there's the figure we have, and the surface area is the sum of all the lateral face, or not all the lateral faces, but just all of the faces. So if I was to take that prism and flatten it out so I could see what I've actually got as far as the different faces of the figure. The net might look something like that. Right? So when we look at the net, 5 inches, 2 inches, 3 inches, 4 inches. So if we wanted to find the total surface area, one way to do that is to find the area of all the individual parts, right? So these are all rectangles. So area of a rectangle, length times width, or base times height, depending on which text you're looking at. So here we have 5 times 2, it'll be 10 inches squared. This one is 5 times 4, 20 inches squared. It's 2 times 4, 8 inches squared. Of course, we have copies of all those. Right? That one's going to be the same as the one on the other side. That one's the same as the one at the top. And the big one is the same as the other big one, which is 5 times 4. All right, so if we wanted to come up with the surface area, capital S for surface area, then we've got 8 plus 8 plus 10 plus 10 plus 20 plus 20. Add them all together, and the surface area is going to be 16, 26, 36, 56, 76 inches squared. So that's one way to figure it out. You can figure out what the net is, find the area of each individual part, and you come up with one value for the total surface area. Now, Problem 12.2 actually gives us a little bit simpler way to do that. It tells us the surface area S of a right prism can be found using the formula S equals 2 times B plus P times H, where B is the area of a base, P is the perimeter of a base, and H is the height. All right, so figure out 2 times the area of the base plus the perimeter times the height. So then, moving on from prisms, we've got cylinders, which are not really polyhedrons because they don't have polygon faces. But a cylinder is a solid with the congruent circular bases that lie in parallel planes. So a cylinder has congruent circular bases. So the top and bottom are circles instead of squares or rectangles or whatever. But it's kind of the circular counterpart to a prism. An altitude or a height is going to be the perpendicular distance between the bases of the cylinder. So the distance from this base to this base at a perpendicular line is the height. A right cylinder is a cylinder in which the segment joining the centers of the bases is perpendicular to the bases. So if I draw a line that goes from the center of the top to the center of the bottom and it intersects at a right angle, then it's a right prism. Or right cylinder, sorry, wrong word. All right, lateral area of a cylinder, the area of the cylinder's curved surface. Right, so if you take the two circles out of it and we just look at the lateral surface, that would give us the lateral area if we found the area of that. And then surface area of a cylinder is the sum of the lateral area and the area of the two bases. Right, so two bases, they're circles, so we've got pi r squared for the area of each base, and then you would find the lateral area, which would be 2 pi r times h, which 2 pi r is circumference, right? So if you knew the circumference of this circle, then you know how far it is around this edge of the lateral surface, and then the height would give you the other side. Which if we flatten this out, it would just be a big rectangle, right? So surface area of a right cylinder, it's basically the same formula as area or surface area of a right prism, which was 2 times area of the base plus the perimeter times the height. This is 2 times the area of the base plus, now I put C instead of P because circles don't have a perimeter, they have a circumference. But basically it's still the distance around the figure, right? So circumference times the height. Which is a nice thing with circles, or with cylinders, is the bases are always circles. Prisms, you can have any kind of different polygon as the bases. So your area formula is different for every one of those. But when it's a cylinder, the area of the bases is always 2 times pi r squared. And then for the circumference, it's always 2 pi r, and then times the height. So actually, it's easier to find this information, or surface area of a cylinder, than it is for a prism in a lot of cases. So I want to find the surface area of the right prism. All right, so this time, instead of flattening out a net and figuring out the total area of each individual part, we're going to plug it into this formula here, 2 times area of the base plus the perimeter times the height. So when we look at this figure, the bases, those are going to be rectangles, right? So capital B for area of the base, the formula we use for area of a rectangle is length times width, or base times height. I actually like length times width better in this case because we're talking about a prism that has bases, and then you look at the base of a polygon times the height, kind of confuses you, so focus on length times width. And then the other formula we need, and there is the perimeter, which is 2 times the length plus 2 times the width. So in order to plug it into S equals 2 times area of the base plus the perimeter times the height. First, we're going to find the area of the base, which is length times width, or 16 times 4. 64 centimeters squared. For the perimeter, we have 2 times 16 plus 2 times 4. That would be 32 plus 8. 40 centimeters. And so once we have those, then we can plug it into the surface area formula. Capital S for surface area. And 2 times area of the base, so 2 times 64 centimeters squared, plus the perimeter, 40 centimeters, times the height. So the height is 9 centimeters, the distance between the two bases. So our surface area is going to be 128 centimeters squared plus 360 centimeters squared. Our total surface area is 488 centimeters squared. All right. So the next one, this figure is a triangular prism. And if we look at the triangle, all 3 sides are 6 inches. So that makes it a equilateral equiangular triangle. So when we go in to figure out the area of the base, they didn't give us a height, right? So normal triangle area, we would do 1/2 the base times the height, which in this example they didn't give us a height, which we could go through and figure out the height, right? We could split this in half and use this as the hypotenuse. 6 is the hypotenuse, 3 is this side, and then figure out this side over here. Or there's an actual formula for area of a equilateral triangle, which is 1/4 of the square root of 3 times the side squared. So the area of the equilateral triangle. And for the perimeter, this would be 3 times the length of the side. You got 3 sides that are all the same. So come down here, get all the parts together. Area of the base, it's going to be 1/4 of the square root of 3 times 6 squared. That'll give us 1/4 the square root of 3 times 36. And if you multiply 1/4 times 36, or divide 36 by 4, to give us 9 square roots of 3. The perimeter is 3 times the length of the side, or 3 times 7, which is 18. 9 squared is 3 inches squared for the area of the base, and 18 inches for the perimeter. And then plug that into the surface area formula. 2 times area of the base, 2 times 9 square roots of 3, plus the perimeter times the area. I want it to draw that a little bit smaller here. And so area of the base, 2 times 9 square roots of 3 plus 18 times the height, which is 10. 18 square roots of 3 plus 180. Or if you were to plug that into a calculator and multiply it out, 18 square roots of 3 plus 180 would be approximately 11.2 inches squared. So either one of those would actually work. 18 squared is 3 plus 180 would be exact. 11.2 inches squared would be rounded a little bit. All right, find the surface area of the right cylinder. So right cylinder, we can use the surface area formula for a cylinder, 2 pi r squared plus 2 pi r h. So in order to do this, all we need is the height and the radius, really. Right, so radius is 4 inches, height is 8 inches. Actually, those are meters, sorry. So surface area, 2 pi times the radius squared plus 2 pi times the radius times the height. That'll be 2 pi times 16 meters squared plus 2 pi times 32 meters squared. There's 2 times 16 is going to give us 32 pi meters squared. 32 times 2 is going to give us 64 pi meters squared. So in terms of pi, it's 96 times pi meters squared. Or if you were to actually multiply that out, it would be approximately 301.44 meters squared. .44 is rounded because remember pi is never ending decimal. All right, so the last one here, find the right height of a cylinder that has a radius of 9.5 inches and surface area of 925.2 square inches. So in this example, we're going to use pi as 3.14. So we know the surface area, 925.2, and the radius 9.5. And we're trying to find the height. So surface area 2 pi r squared plus 2 pi r h. So plug in the values we know. Surface area 925.2. It's going to equal 2 pi times the radius, which is 9.5 squared, plus 2 pi times the radius of 9.5 times the height. It'll be 2 pi times 90.25, we square that, plus 2 pi times 9.5 times h. That'll be 180.5 pi plus 19 pi times h. We plug in 3.14 for pi. Becomes that. It's 925.2. We'll play that out. That's going to be 566.77 plus 59.66 h. Subtract 566.77 from both sides. It was 358.42 or 43, sorry. Yeah, 43 equals 59.66 h, and divide by 59.66. 6.0079 equals h, or 6.0 inches equals our height.